Greetings, my name is John Gabriel, and this is the New Calculus channel. And today, I'm just going to have a casual chat with you about how I began to study calculus and how I arrived at the New Calculus, or what led up to the New Calculus. I was about age 13 or 14 when I began to study calculus, and I grew up in a very poor family in a poor area, a little tiny library which was about the size of maybe 15 by 15 foot room, had only one set of valuable books, the Encyclopedia Britannica. Now, I actually used to start off reading, and I would just see something that I didn't understand, and I would follow the topic and veer completely off whatever I was on. So I had a tremendous thirst for knowledge. I would read the Britannica all the time. I really didn't have time for non-fiction books like, novels, which most people read. I think most of the novels I read were the ones that were recommended at school, which I had to read in order to pass my English classes. So I read non-fiction books, and mostly the Encyclopedia Britannica. The Encyclopedia Britannica isn't easy reading, and so I'm going to show you what I started off with now. Let me just turn the camera off. Okay. So I wrote a 20-page article, almost 20 pages, on how we got calculus. And don't worry, I'm going to put a link to this in the details section, and you can read it in your own time. This article is invaluable. It's better than any book you've read on calculus. It's better than any calculus course book, especially a first semester course. And you'll see things in here and understand how they came to be without all the absolute rubbish that your moron orangutan lecturers tell you, who don't have even an inch of my understanding of calculus. Nobody understands calculus as well as I do, okay? So, well, you'll see when you read the article. At any rate, when I first started out, this was one of the articles I read in the Britannica, and it was on page 602, and it was covering the topic on the calculus of differences. And so why is this topic important? Well, because this is the topic that leads up to the interpolation polynomial of Newton, which was, by the way, extremely useful, and Taylor series can be derived from it in just a few steps. So imagine yourself as a 14-year-old reading this sort of thing. Right? See, many things here, initially I was unclear and I thought it was wrong, and then I found out it was right. I didn't have any guidance. My stupid teachers wouldn't even be able to understand even one paragraph out of this. So I was on my own. I had nobody to help me, and I read, and sometimes a little tiny proof, where it would say, this is easily demonstrated. Could take 3, 4, 5 pages, So this was the first part I began to study here, and it interested me because this is a way to approximate numbers that can't be measured, for example, like pi and everything else. And finite differences is normally a topic that is only covered in, advanced mathematics courses, usually in postgraduate courses. It's not the kind of thing you'll do in mathematics. You may do it. In my case, we actually covered a lot of this theory in mathematical statistics in a course I took at university, because this is stuff that you need to know to be able to do a lot of the things you do in statistics, okay? So many of these topics here were at first completely strange to me, and it took me quite a while to understand. Now, here's another page where I went on to, and this particular section here deals with integration. First numerical integration, and then obviously the summation problem, which you see over here. I mean, imagine reading this for the first time, even as an adult. But I was still a teenager, and I actually understood this. It took me probably about 6 months from the time that I started to get to the bottom of all of this. And I found this to be extremely fascinating. And even though I understood most of it, there were things that didn't quite fall into place. For example, I could never make the connection between the integral and the integral and the derivative. It took me a long time to make that connection, and I did eventually find it. That's called the missing link. So this is the kind of thing that I was doing when I was about 13 or 14. My teachers definitely wouldn't have been able to teach any of this. They simply didn't have the ability. Okay. Now, so a lot of these concepts here, I mean, I was just studying everything, even complex numbers, how to evaluate Fourier series. I did a lot of work on anything and everything I could lay my hands on. I would try to figure out how they work. And here you can see the beginnings of where I started to use m plus n, and which that despicable, vile creep, Professor Gilbert Strang from MIT, once said I shouldn't be using because they're not used as real numbers, but as integers. In fact, they were used a lot in the Britannica and many other places. So this here was about 90 or 100 pages of scrap work, which I scanned and kept on a disk because I wasn't carrying around. I didn't want to carry them around with me anymore. But you'll see things like the Chronica Delta. You'll see improper integrals. I was studying a lot, and I had a very wide knowledge of the mainstream calculus and how it worked. Everything from identities to Coates' formula, which I proved here. This was all the proof of Coates' general integration formula. And this, when I proved this, I felt like I was invincible because it was one of the most difficult proofs that I had to do. So I studied finite differences, and I studied things like reciprocal differences, always wanting to get a deep understanding. And I did actually acquire a deep understanding. And also I worked a lot with scrap paper. So I used to save finite difference tables which I had worked out so that I could use them in, Newton's interpolation polynomial. But this is quite an interesting document because it contains a lot of things that, I was at the time working with, even contour integrals and how to evaluate them. So it's quite an interesting document to look at for somebody who, especially looking at it after all these years. As you can see, again, I would take any scrap paper. I don't know who this was, one of the famous tennis players. But here's Cauchy's contour integral, and also at some or other point discovered my average sum theorem, not from the integral, but I would write down everything. I would study the path integrals and how they work. And as you can see, a lot of complex numbers there, even though a complex number is an ill-formed concept. So at any rate, I spent a lot of time studying the mainstream calculus. Now, my article here is one of the best ever written articles on how we got calculus. And I Remember, I was also pretty young when I wrote most of this, so you might see some obvious expressions, like in the days of Newton, there were no calculators. You might say, duh. Yeah, but I was pretty young then, so, and probably a little innocent, and I didn't really care too much about stating the obvious. But this is a fascinating article, okay? I did update it later on, and it does contain quite a lot of typesetting and stuff that I couldn't do back then because most of this was handwritten. But I tried to explain this in a way that, even a high school student can understand it. It's a beautiful document. It takes you through all the proofs of the finite differences. It shows you the Gregory series and eventually gives you a general formula for a finite difference, as you see there. And following throughout, you get a restatement of the differences in terms of Gregory, and then eventually the formula for the interpolation polynomial, and from it the Taylor polynomial, and many other interesting ways of stating derivatives. So it's literally a gold mine. And this last section here was an update because this came many years later. This is the Gabriel polynomial, which is quite fascinating because it's always in closed form. Okay, so this document is amazing, and it's 20 pages, but it will take you a very long time to complete studying. So I hope you've enjoyed this little presentation and that you'll join me again next time. I'm running out of time. This is a new calculus channel, and I spoke to you about how we got calculus, and next time I'll try and explain a little bit more by breaking down all the topics into smaller sections. So, till next time, goodbye.